Hello and welcome back to my channel. In this week's video I will be upgrading some parts on my CoreXY 3D printer that I built myself, and I am upgrading all the parts on it until it's the perfect 3D printer. In this week's video I will be upgrading the motor bracket in the back to a new design that is better and improved and easier to assemble especially. So now let's get into it. So the parts that I changed on the new design was basically this motor holder in the back, and I combined it with the bearing holder. So before it only went up to here, then it went it was done right there, and now they are merged with the block that holds the bearings. And I split the top part off, so I took the top part off in the design, so I am now able to put the bearings into these holes, the axles, and then put the bearings on without having to put them in like from the side. So this is just for assembly. It's a way better design. And it's also easier to print than the old design, because this design right here only uses supports on these slots right here and as well in this slot. But I am thinking that I will probably just be able to leave this entire thing away. So just cut this off and also leave this away, because it is sitting on the profile right here, and that's already enough stability, because also the bearings, all the forces will pull this entire assembly to the middle, so it will just be resting on here and then be screwed down from the top with these screws into special nuts that are inserted into the profile. And I think this is a way better design, because it's more compact, because I was able to put the motor over further to the side compared to the previous design, where there was a wall that I could get rid of, because I put the hexagonal thing for the nut in the other part, or better said in the side of the previous part, and then I merged them, so now I can just put them further over because there's nothing in the way anymore. And now let's just print these parts out and then put them on the machine, and then we can see what problems will maybe emerge from that. I still don't have a camera that can do these fancy time lapses, so this will have to do. And after that I had to drill out the holes for the axles, for the bearings, and just in general. For that I use a cheap broaching set that I bought. They are not accurate at all. They're like a 1/10 of a millimeter oversize on most parts, but for these pins they work out just fine. As you can see, there's some play, but not too much. And now I just have to do that 8 more times. Here you can see the hexagonal cutout that I made for a nut to be placed in. So I can use the normal M5 screw to tension the motor, or the belt better said. The hexagonal cutout was a bit loose, but I will change that in the design in the future. And now we can take out the old parts and put in the new parts to see if they fit. And they did fit, at least as far as I can tell. But I think they worked out pretty good. There were a few things that I noticed that I can improve. For example, on the bottom of these parts there is a extrusion that is the purpose of it is to guide it in the cutout, in the profile, in the aluminum profile. That was a bit loose, but I adjusted that in the design. That's something very important if you do designs like this, is to try it out, make it work, change the design for the future versions. And if you do that, you can really improve anything fairly quickly, compared to if you design for a long time and then you try it out and the core principle of it does not work and you have invested a lot of time into it. It's just worth more if you figure it out, if it works by just doing a very crude prototype, maybe change the existing parts a bit, so you can see if your concept actually works before you change the design and make the new parts. Obviously with 3D printing you can change a part very fast and cheap, but if you have to actually CNC mill something or similar, it takes hours at best and days or weeks if you have to let somebody else make it for you. So it can be quite a bit more efficient if you do these changes just in 3D printing, or by changing the parts by just cutting off a piece of it, or melting a part away that's in the way of the belt, for example. Then you can afterwards go and change it in the design. At least this works pretty good for me. So as you can see, I am able to screw this part on with just 2 screws. And now we're done with the first side, but obviously we have to do the same thing to the other side. So now let's remove everything from the right side of the printer. Something that impressed me was that you can actually see some imprints of the screw heads or the washers in the PLA. So it definitely does deform over time, but it's not too bad, so it's not a real problem, I think, at least not for this part. Then I had to cut open this part because there's no way to actually remove the belt any other way, except for maybe removing both belts on the printhead, but that would have been a lot of work to then completely reroute this. With the new setup you can just remove them. That's also an advantage, that I split the parts there. Now we just have to assemble everything, the motor, and here you can see the tensioning system. This actually works great, but because I changed the design and made it more compact, the distance from the motor to the pulleys in the back was decreased. Because of that I had to shorten the belts at the printhead, which worked very good with the new system. And you can see I for sure didn't forget to put the holes for the end stop. But I had to add it because I forgot. And now I'm adding all the things that I've learned. So the hole right there, I forgot them, and then these extrusions on the bottom, they were too not wide enough to actually help anything. Then these were too low, or not low enough, so you had to use some weird screw. And then I decreased the width, so the motor actually was tightly in this space and would be guided by that. And with that, thank you for watching. I hope you enjoyed this video, and until next week.